Hello wonderful person, this is Anton, and no, I'm not trying to hypnotize you and stuff, even though this does look like one of those hypnotization thingamajiggies. But at the same time, what you're seeing right here is actually a visualization of the now famous phenomenon referred to as the gravitational waves. The phenomenon we discussed previously many times, and the phenomenon that was originally predicted by Albert Einstein. But he actually believed we would never find them because the amplitude of these waves is extremely small, smaller than a typical atom in size. Yet despite of this, in 2015 there was a major breakthrough from the facility referred to as LIGO, Laser Interferometer Gravitational Wave Observatory, a detector in the US that for the first time in history detected a signal from two merging black holes 1.3 billion light-years away from us. This eventually resulted in a Nobel Prize in Physics in 2017. And this was the official birth of the now famous gravitational wave astronomy. Astronomy that's based on observing something entirely different that was previously impossible. So instead of using traditional telescopes that observe things in the electromagnetic radiation, gravitational wave detectors hear the universe by observing individual fluctuations of space-time itself, which is what this here kind of shows us, but could also be visualized in this way. So this is actually something that's happening to us even right now, because as we've discussed in one of the recent studies, there is a kind of a persistent gravitational wave thing going on that seems to be happening at all times, although right now nobody is entirely certain what's causing it. Either way, you can learn about this new mystery in one of the videos in the description. But in this video, we're going to be focusing on this new detection that once again surprised everyone because it just does not really make a lot of sense. And specifically here, in 2024, scientists discovered a new black hole collision, once again involving a binary black hole system, but that in this case, for some reason, also resulted in a massive emission of X-ray radiation, along with the gamma rays, that currently make no sense because normally, once black holes collide, they don't actually produce any light. I mean, by definition, they are called black holes because they're generally black. So by definition, nothing, not even light, can escape them. And so whatever happened here seems to challenge one of the most basic rules we have about black holes, because on November 25th, 2024, scientists detected a massive collision that after 11 seconds was followed by a sudden flash of light. And based on the masses of these objects, they seem to be black holes and not neutron stars that we normally expect to produce these types of emissions. And so in this video we're going to discuss this very strange event, S241125N, that's now providing us with a very interesting look into some of the most extreme environments in the universe. The event that was finally analyzed and described in a study you can find in the description. This is actually a really intriguing study, mostly because it's trying to figure out exactly what caused the emissions and how these black holes were able to produce light. But here the story, as always, starts with this ripple in space-time, or essentially a kind of a ripple in the fabric of the universe. Here, the LIGO Virgo Cagliari detectors picked up the same gravitational wave from a merger approximately 4.2 billion light-years away from us, and this collision involved two black holes that merged into something that produced a relatively massive object, 150 solar masses in mass. In other words, they actually produced a kind of an intermediate mass black hole. And so the only way to explain these masses is that this had to be two black holes of already pretty massive proportions. But it was really what happened in the next 11 seconds that basically surprised everyone. Here, after the gravitational wave passed the planet, which I guess could be visualized this way, additional telescopes, including the Einstein probe and the Swift telescope, started to receive X-rays and gamma rays that seemed to be coming from the exactly same spot in the night skies. And obviously these could be completely unrelated. Here, if we consider this to be by chance, or if we think this is some kind of a random coincidence, it would be extremely unlikely to happen because we only expect one such event to happen every 30 years. And well, that's of course the mystery of this particular collision. How can black holes end up producing powerful X-ray and gamma-ray emissions, which is of course what's tackled in this study. And so basically, if the black holes are dark, where did the light come from? And a team of astronomers led by Shu-Rui Zhang suggests that this collision most likely did not happen in empty space because otherwise this is just impossible to explain. Instead, they now believe this very likely happened inside some kind of a massive accretion disk of a much larger supermassive black hole. This is actually the illustration potentially showing us what happened here. And so here we had a supermassive black hole in the center of some kind of a distant galaxy that we currently do not see, unfortunately. which involved what we refer to as the active galactic nucleus, essentially a very active black hole with a massive accretion disk. And normally these disks are absolutely giant. They essentially resemble a kind of a rolling whirlpool of gas and dust that ends up being so hot that it starts to shine just like a typical star. And that's usually why we see certain black holes from a distance. It's not the black hole, it's actually the disk. But here inside this disk, there was also a kind of a binary system, or possibly black holes orbiting very close to each other, that were obviously much smaller in size. The supermassive black hole could be in billions of solar masses, but these two individual black holes were only 70 to 80 solar masses. And then they essentially merged. And when they merged, the process was not perfectly symmetrical. In other words, it resulted in a kind of a kick, with both objects now moving at a relatively high velocity, possibly several hundred kilometers per second, with this massive recoil now sending the newly formed black hole right through the surrounding gas and through the disk itself. And it was very likely this that then produced enormously powerful emissions. So basically here this new black hole plowed through this dense disk material and started to actively feed on all of this gas rapidly, in the process creating a relativistic jet, producing huge amounts of energy, but also launching matter at nearly the speed of light. But because it took approximately 11 seconds to reach this point, it explains why we seem to see a slight deviation between the light and the production of gravitational waves. Or at least that's basically the best explanation we have as of 2026. And to some extent this does corroborate a lot of other previous propositions that have already suggested that one of the main reasons we seem to see so many black hole collisions, or basically 10 times as many as scientists expected, is because the majority seem to be always happening extremely close to these central black holes, where millions of these objects seem to be in a constant orbit, which has also been proposed in regards to the central black hole in the Milky Way galaxy, where many scientists propose that there could be up to 1 million different black holes within approximately a few light years away from the center. But this is the first time that the black holes ended up plowing through the dense gas of the accretion disk and created the shock wave that triggered its own accretion. And this is of course important because historically we've only seen these emissions coming from the collision of neutron stars. This is usually when they produce some kind of a kilonova. And so if confirmed by other studies, this will be the first time ever scientists have seen a black hole merger using both gravity and light. So basically this will be the first black hole collision producing actual light emissions and not just gravitational waves. But naturally this is not the only unusual collision discovered in the last few years. As a matter of fact, quite a few of these strange signals have been discovered previously, with some of them being so influential that they basically kind of rewrite what we thought we knew about black holes and various collisions. Now obviously one of the most influential collisions was back in 2017 when we witnessed the collision of neutron stars, which unlike black holes do produce kilonova. And this was the first time that scientists were able to confirm that a lot of heavy metals, and of course things like platinum and gold, seem to be caused by these enormous collisions. But there was also a very strange event in 2019 that also involved two relatively massive black holes, 85 and 66 solar masses, that then produced another intermediate mass black hole. But the problem here is that the signal was extremely short, lasting only approximately 0.1 seconds, and did not match any other collisions seen previously. As a matter of fact, there was also possibly another electromagnetic emission that was observed approximately 34 days later. And so there might have been another one of these black hole collisions that seemed to have occurred very close to an accretion disk of a supermassive black hole. And so for all we know, this is maybe a very common phenomenon, but obviously only future detections will confirm this for sure. But then there were also reports of unusual bursts with a signal without a clear origin. And so there's actually been a few cases where scientists observed some sort of a collision that even today cannot be explained. And so for all we know, at least some of these collisions could be between some unusual objects or even exotic objects, with some scientists even proposing objects like, for example, quark stars, and not just typical neutron stars or typical black holes. In other words, of hundreds of signals discovered so far, some of them are definitely beyond expectations and do not resemble standard mergers, which makes events like this one particularly important, mostly because they now turn black holes from some kind of a theoretical mystery into an actual empirical study where we can study various emissions and various types of ring downs or changes in frequency in helping us understand how these objects evolve as they collide and merge into a single entity. As a matter of fact, the newly formed object usually vibrates like a kind of a bell that was struck with something heavy that can actually then help scientists test various fundamental laws of physics. As a matter of fact, something like this has even been done recently, when scientists studying various mergers managed to confirm Stephen Hawking's area theorem, or the idea that states that the surface area of a black hole can only grow and never shrink. And at the same time, by studying these, it also helps us understand a little bit more about the source galaxy, or basically the host galaxy, where all of this seems to be happening. Either way though, even after approximately 11 years, there is still so much to learn, and this field is only getting more complex and more intriguing. As a matter of fact, with the new data coming in pretty much every week, it's only a matter of time before we discover something even more incredible and something even more surprising. For now though, these types of emissions serve as a kind of a reminder that the universe is a lot more crowded and a lot noisier than we once believed, and does seem to have a lot of different collisions happening at all times. On that note, thank you for watching, subscribe, and okay, wait a second. Okay, yeah, let me hypnotize you. Support this channel on Patreon, and maybe buy the Wonderful Person t-shirt, and maybe subscribe, and also join the channel membership and stuff. Either way, we'll definitely come back and discuss this more in some of the future videos. Stay wonderful, I'll see you tomorrow, bye bye.